Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to everyone. So inshallah today we'll continue with the slide that we stopped on Monday, which is folded uniform quantization. Okay, so this is the formula for folded uniform quantization. If you notice, um, we have two different sets of equation. Okay, so depending on whether it's positive or negative signals. Okay, so in this course, the sign bit that we use for positive is 1 and for negative is 0. Okay, so we'll start, the lowest code is 0, 1, 1, 1, 1 and so on. And maximum 1, 1, 1, 1. So the first MSB, most significant bit, represents the sign of our PCM code, while the rest, the remaining bits shows the magnitudes. Okay, so the total N includes both sign and magnitude bits. If, for example, we use N equal to 7, the first MSB is for sign, and 6 other bits will be our magnitude bits. Okay, here in this equation, we want to define some parameters. Y is the decimal value of the magnitude bits, and Z is decimal value when all magnitude bits equal to 1. Okay, for example, in this 1, 1, 1, the value of Y is equal to Z because it's 1, 1, 1. Let's try another. Okay, let's see 1, 0, 0. Y value is 0, but the Z value is 3, 1, 1. So we get better understanding when we solve the question related to this. VKL and VKH are the lowest and highest levels of quantized voltages. Okay. So this is the equation for if our codes are positive and this negative. Okay. So V is equal to, for positive, we start with VKH, because we start from above here. Okay, so we can actually divide this into two parts. Okay, so I'll divide this. So this is the, and the below one is the negative, while the above one positive. Okay, so if our voltage is somewhere, maybe around this, we'll start with VKH. Okay, on top is VKH. And then the difference between this is Z minus Y times delta V. Okay. Okay, so VKH, then minus Z minus Y times delta V, then we can get the quantized voltage at this point. Whereas for the negative, if our points is here, so we start with VKL. Okay. So obviously, if you want to move up, we have to plus, then it becomes Z minus Y times delta V. Z is because the magnitude bits around here is the decimal values of magnitude bits. At this point is Y, over here is Z. So Z minus Y times delta V, we get the quantized voltage at this point of Y here. So when we get the answer for positive, we have to add. Once we get what we solve, we get Y. So this is the decimal value, change to binary, and whatever answer we have for the binary bit streams, we add 1 in front, okay, as our sign bit. If it's over here, our answer we add bit 0. Okay, so that shows the negative sign bit. Okay, so you have to remember, for if our signal is negative, it's from VKL plus Z minus Y times delta V. For VK, for positive, it's VKH minus, and we cannot VKH plus because this one is already the highest level. Okay, of course we cannot go up. It's illogical. So we have to, if VKH has to be minus, VKL has to be plus. Okay. VKH minus Z minus Y, VKL plus Z minus Y. Okay, let's try example. Actually, it's the same question like the previous, previous non-folded. It's just that now, instead of solving using non-folded, we solve using folded. Okay. So the number of levels, okay, the ABC should be similar, whether it's non-folded or folded, should be similar because number of levels is 2 to the power of n. LSB voltage or the quantization interval is V peak to peak divided by L. Okay, so please don't get confused lah. And this is L, quantization levels, and this is delta V, quantization interval. This one. Maximum quantization noise or error is delta V divided by 2. And the voltage value for 110, 1101. Okay. So to solve this, okay, first we check. We use 7 bits, 1, 2, 3, 4, 5, 6, 7. So the MSB here is 1. So it shows, so this is positive. Okay. Positive. So first we need to, okay, we use this formula, voltage is equal to VK, since positive, is VKH minus Z minus Y times delta V. Okay, so we need to find VKH. In order to find VKH, okay, since it's VKH, we need to use Vmax lah, Vmax minus delta V over 2. Okay, so our Vmax in this case is plus 16 delta V over 2. Okay, we have already calculated actually from our last example. This is 0. Minus our delta V here, from here delta V is 0.25. Okay, so here is 0.125. So VKH is equal to plus 15.875. So this is our VKH. Okay, we need to also find what is Z and what is Y. So Z is when our magnitude bits all equal to 1. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6. All 6 bits equal to 1. So it's 63. Whereas Y is magnitude bits of this point that I want to solve. So it's 101, 101. 10101 is 45. So And we know that Z is equal to 633 and Y is equal to 45. So we just put inside our formula. Okay, voltage is equal to plus 15.875 minus Z minus Y, 63 minus 45, 18 times 0.25 for our delta V. So we got the answer plus 11.375. Okay, so this should be the voltage value for 1101101. Okay, so since it's 1 here, put positive. Okay, so this is for the D, answer for D. For second 0011001, okay, for this part, since it's positive, we'll use, we start with VKL. So, be slight difference with in our equation for E, VKL plus Z minus Y times delta V. So, for VKL, let me erase first. Okay. VKL. So here, our VKL is equal to V min plus delta V over 2. Our V min is negative 16 plus 0.125. So we get minus 15.875. Okay, so this is our VKL, and the lowest quantized voltage. And here, Z is 63, Y, and it's 11001. 11001 is 25. So Z minus Y is 38. Okay. So the difference between them, Z minus Y is 38. So we just put inside our equation here, voltage is equal to VKL minus 15.875 plus 38 times 0.25. Okay, this equation. So you get the voltage for the this code 0011001 is equal to minus 6.375. Okay, so this is the answer for E. Yeah. Okay. So you have to take care. For folded, you need to pay attention on the bits, MSB, whether it's 1 or 0. 1 positive, start with VKH. 0 negative, VKL. Okay. So code for input. Let's look at the next question. Code for 13.62 volt. Okay. So let me use whiteboard. Then it will be more spacious. Okay, what is the code? If you are given voltage is equal to 13.62 volt. Okay, so we know voltage is equal to VKH minus Z minus Y delta V. So 13.62 is equal to VKH is 15.875 minus 63 minus y times 0.25. Okay, so when you solve this, you got y then is equal to 53.98, which is around 54. So 54, this is in decimal. Okay, so 54 decimal is equal to 110,110. Okay, 110,110. So this is what we got. It's our y. And since it's positive, we have to add with 0 in front. So our code, PCM code for this voltage value is equal to 110,110. Okay. So this one we put to the answer. This is answer. And then we add. Don't forget to add. Okay, bit 1 since it's positive. Okay. Next is when given our voltage is equal to minus 9.37 volt. Okay, so with this we use voltage is equal to VKL plus Z minus Y delta V. So our VKL is minus 15.875 plus 63 minus Y times 0.25. Okay. So here voltage is minus 9.37. So just when what is our Y? If you solve this, you should be able to get your Y to go to 36.8, which is around 37, which is equal to 100, 101. 100, 101. And since it's positive, since it's negative voltage, we add 0 in front. So our PCM code is equal to 0, 100, 101. Okay, so this is our answer for the last part. Okay, so actually if the number of bit is not too high, 3, 4, I think 4 is, if you have n equal to 4, then your L is equal to 16. It's still quite manageable to draw the quantization scheme. Quantization scheme, you need to write down the levels from the number of levels from 0, 1, 2 up to 15. And then what is the code? And the code 0 is 1, 1, 1. Okay, this one 1, 1, 1, 1, and so on. Okay, where in the middle you have 0, 0, 0, 0, and 1, 0, 0, 0. Then you quantize voltage. Okay, quantize voltage for that level. So this one you just use formula lah. For VKL is V main and VKL. So this is the VKL. This is where you have the lowest level, VKL, which is equal to V min plus delta V over 2. And up here is the highest VKH, which is V max minus delta V over 2. Okay. And then for the, if you go down one level, just for, and if 15 to 14, for example, just minus delta V. From 15 to 14, just minus delta V. If you and then so on and so on. The same thing here. If you go up one level plus delta V. So if it's you can, if you don't want to use formula, you can use this manually. But like I said many times before, if your n is high, like 7, 8, where you have hundreds of levels, 1 to 8 to 5, 6. So it's very difficult. So then you need to use formula. But formula, if you understand, it's also it's very easy actually. All right. So I'll stop here first. Oops. And then continue with the next part, okay, which is non-uniform quantization.